Hello everyone, I am Indrajyoti Gaine and presently I am a PMRF fellow and I am pursuing my PhD at Department of Mathematics and Statistics at IIT Kanpur, and before that I was a CHR fellow and I have cleared my CHR net with 108 rank. Okay, so today we will discuss about the topic permutation and combination. So for that, we need to be aware of why we need these two concepts. So suppose you have a bag. So nowadays everyone use a trolley with keep number lock, and number lock is a very secure lock. We know about this. So what is the number lock? So in case of trolley, there are like you can see some kind of number lock like this, where you have three or four number wheels. Like here is a wheel, like here numbers are from 0 to 9, 0 to 9, like 0 to 9, 0 to 9, 0 to 9, and 0 to 9. Okay, now usually when we buy a trolley, then we can see that the number is 0 0 0 0. So usually the lock was 0 0 0 0, but we can set our convenient lock or convenient number lock depending upon our choice. Now the question is, suppose someone forgot this number lock or she had chosen, then he must try to unlock this trolley by different patterns or different combination of numbers. The question is, how many how many different pattern he or she need to try to unlock this. Okay, so for that one can count many different combination. Like for that one can count like this. For first one was the 0 0 0 0, then 0 0 0 1, then 0 0 0 2, and so on. After that it will come like 0 0 1 0, 0 0 1 1, and so on. Like this you have to write a particular combination, and at the end you have to count how many combination of four different numbers you obtain. Correct? Now the question is, can I count this number without calculating all these numbers explicitly? That is, can I count how many combinations we need to try to get all possible number combinations without writing the combinations explicitly? So for that, just watch one thing. Here we have 0 to 9. So we can use 0 to 9. So there are some choices. Similarly, here are some choices, 10 choices. So I can put any one of that number. Here also you have 10 choices. Here also you have 10 choices. So I know the choice of each block, but we don't know the number of total possible number of combinations. So this is the primary motivation of studying this permutation and combination. Okay. Now one can ask that, or one can ask the similar question, like, okay, some case this may happen that I have this similar lock, 0 to 9, choices are 0 to 9, 0 to 9, and 0 to 9. Then number will lock. Now here there is a condition. The condition is no number will be repeated. Number will be repeated. Okay. Now here you can see that I had 10 choices for each block. So one smart guy can clearly tell me that, okay, this for this block we have 10 choices. This block we have 10 choices. This block I have 10 choices. And for this block we have 10 choices. So if I multiply this 10, 10, 10, 10, that is 4 times, that is 10 to the power 4. This will be our total number of number combination. We need to figure out forgotten password. But what about the second case? Here there is an extra condition that no number will be repeated. Or also one can again say one thing that, okay, in my case, this is my log 0 to 9, 0 to 9, 0 to 9, 0 to 9. Okay. Now I have extra condition. One is no number will be repeated. And second one is if I choose the ordering of the element will not be considered. Ordering of the numbers will not be considered. So you may not get convinced by this ordering property in this example, because 1 2 and 2 1 are not same. Okay, like 1 2 3 4 and 2 3 4 1, these two are not same, right? So for that we should be take another example. That is, okay, I have 3 basket. Okay, I have 3 basket. You can consider this as a basket. Okay. Now I have 10 apples. I have 10 apples. You can say like this. These are apples. You can consider like this. Okay. I have 10 apples. Now I need to put these apples in this basket, in this 3 basket. So how I can put these apples in this basket? So I can have some combination, like here I put 3, here I put 3, here I put 4. Or one can say that, okay, I will not like that. I will do, here I will put 4, here I will put 3. Or one can say that, okay, I will not put like this. I will put here 2, here 5. So depending upon their choice, the number of way to put these 10 apples in the 3 different basket will vary. Fine. Now the thing is, here the ordering is not that much important. Like if I put this apple first or this apple first in this basket, it doesn't matter. Correct? But in the case of number, it will matter. If I put 1 first, then 5, or if I put 5 first and then 1, the numbers are totally different. But in case of material, or in case of elements which are not, which are similar or which are same, in that case the ordering is not that much important. So there one can ask that question, that if I put this apple in this basket, so clearly here repetition is not possible, because if I put one apple in any of the box, then I have only 9 choices of apple. I can't, I don't have 10 many apples. So repetition is not possible in this case. So the first option is automatically satisfying. And what about the second option? the ordering of the number, that is the ordering of the apple, will not be considered. So that is also true because apple don't have any significant number. So if I put the more red one first or less red one first, that doesn't matter. Or more sweet one first or more less sweet one later or first, that doesn't matter. So ordering is not that much important in this case too. Fine. Okay. So the question comes here. How many ways are there to put 10 apples in 3 baskets? So these are the questions which motivates us to study this chapter, permutation and combination. Okay, so let us start with the first fundamental principle of counting. So let us discuss first 2 examples. Okay, so before going to the principle, let us discuss 2 examples. First is example 1. What is that? Suppose you want to go to some marriage ceremony. So you have 3 pants. 3 pants. Okay, not 3 pants. 2 pants. Usually people have less pants and more shirts. So you have 2 pants and 3 shirts. Okay. You have 2 pants and 3 shirts. Now you have to go to some marriage ceremony. Now, how many different choices you have to dress up yourself? This is the question. Okay. So how many ways you have? So you have 2 pants like P and 3 shirt 3S. Okay. So let us denote by P1, P2, S1, S2, S3. So first you choose a pant, or you can choose a shirt depending upon your choice. So I will first choose a pant. So how many ways I can choose a pant? I can choose a pant on my 2 ways. Why 2 ways? Because maybe the pant color has different color. One is of red color. I'm sorry. One is of black color, and one is of white color. Okay. So let us write that like this, so that you can understand properly. One is of red color and one is of white color. And what about the shirts? Say shirt has different color, like one is of color red, one is of color green, one is of color white. Okay. Now you need to find all possible combinations of dress up yourself. Then how many ways you can dress up yourself and attend the marriage ceremony? Or one can ask that how many marriage ceremony I can attend by combining or by using this many shirts and pants. Because usually people don't have usually in our class we don't use different dresses for different marriage ceremony. We usually use our havings, that is we already have which pants and shirts for the marriage ceremony. So we can combine all those things that so that we look different in different marriage ceremonies. Okay, so for that I have 2 pant, white pant and red pant, or you can say white pant or red pant. Fine. So How many ways you can pick a pen? So that is, there are two ways. Either you choose a white one or you choose a red one. So you have two ways. Now for a white one, you can wear the red shirt. With white one, you can wear the white shirt. With white one, you can wear the green shirt. You can wear the green shirt. Similarly, for red one, you can wear the red shirt. You can wear the white shirt. You can wear the green shirt. Okay. Then just see the combinations. How many combinations we obtain from here? We obtain, first one is uh, white shirt, red pant. Second one is white shirt, white pant. Sorry, white. Yeah. Third one is white pant, green shirt. Then second one is red pant, red shirt, red pant, white shirt, and red pant, green shirt. Now you can clearly see from here that we obtain 6 different combination of dressing up yourself, and all the possible combinations are somehow distinct from each other, right? So we have so we have 6 many different combinations. Fine. From here I can see clearly this. Okay. Now consider another example. Example 2. That is, you have 2 bags, 3 tiffin box, and 2 water bottle. Okay. So how many ways you can combine them to take it to the school? Okay. So for that you can I can write like bags for B1, B2, B1, B2, tiffin box for T1, T2, T3, water bottle for W1, W2. If I draw the tree like this, previous tree like this, so how I can write this? So I have 2 bags. So I have choice for bag is 2. Now each choice I have 3 choice of tiffin box, right? Because inside I have chosen the first bag. Now in that bag I can put either of the tiffin box. So for the choice of different tiffin box, I am getting a different kind of combination. Now depending on the tiffin box, I can choose 2 different water bottle. Fine. Okay. This is the problem. Wow. Okay, fine. Right here, W1, W2, W1, W2. Okay. Now for each T1, I have W1, W2, W1, W2, W1, W2. Similarly for this T1, T2, T3, W1, W2, W1, W2, W1, W2. Now you can combine all those things: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I am not writing all the combinations just for saving time. So here you can see the counting the number of dashes that here are. We have 12 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So there are 12 choices. So I can have 12 different combinations. 12 different combinations. Okay. Now from above and from below, can you say by just from here, just by watching the statement, how many choices I can have? Now I have discussed how we are getting different choices. Now can you say that from this example 1 and example 2, that just by watching the statement, or just by getting the number of different choices or different like bags, tiffin box, how many tiffin box I have, how many bags I have, how many water bottle I have, depending upon these numbers, can we say the number of possible combinations? So here you can see the possible number was 6. Number of combination was 6, which is nothing but 2 into 3. Similar way, in the later case, 2 into 3 into 2, that is equals to 12, which is the number of different combinations of choosing the bag, tiffin box, and water bottle. Fine. So this is called the fundamental principle of counting. So what is the fundamental principle of counting? The statement is what is this saying? It is saying that if an event can occur in m different ways, following which another event can occur in n different ways, in n different ways, then the total number of occurrence of the events in the given order is in the given order is m cross n. Okay, what is the statement? This saying that if an event can occur in n different ways, and following that event, another event can occur in n different ways, then the total number of occurrence of events in the given order is m cross n, or mn, you can say. So clearly you can see here, the first event was choosing of the bag. Choice of the bag was the first event, and following this choice of this bag, we have chosen three. We have choice of 3 different tiffin box. So the choice of tiffin box was following the event, the choice of bag, and the choice of water bottle was following the event, the choice of bag and choice of tiffin box. Okay, so in this case, the number of event for the first case was m. If the second case is n, then the total number of occurrence of the event is m cross n. And if the case is for like 3, like in the case of the second example, you can see there are 3 events following each other. In case of this thing, the following number will be m cross n cross p. depending on the number of events or number of occurrence, you can say. So number of ways possible, number of possible ways. Okay. So in the case for 3, we will get m cross n cross p. So let us add some statement. Note: if following these 2 events, third event occur in p different ways, in p different ways, then the total number of occurrence of the events, occurrence of the events is m cross n cross p. Okay. So this is the fundamental principle of counting. Okay. So let us do one example. So example is that example 1. Okay, example using this fundamental principle of counting, we can do a different try an example. The example is find the number of whole letter words with or without meaning. Why this is important? Because let me write the question first, then I will discuss. Which can be formed out of the letters of the word R O S E, where repetition of the letter is not allowed. Okay. So what is the question? That is stating that we have to find all possible how many numbers I can form using the 4 letters, that is R O S E, which has meaning or which has no meaning. Just we need to combine those words, and we will get some word that may have meaning, that may not have meaning. Like if I use the 4 words, if I write the word like O S E R, I don't know if this word has any meaning or not. If I may write like SORE, I may write like ROES, I may write like RESO. So all possible words are allowed. Just stating this thing, that with or without meaning. If they say that with meaning, then these possible words are not allowed. Maybe only this, maybe possible that only this word is allowed, others are not allowed. But here by this statement, they are saying that these all are allowed. So I can just I can write anything, any combination I can write. So how many ways I have, or you can say how many numbers of 4 letter word I can find by this process. Okay, so let us consider this box. Can consider this box. Okay. Now here one thing extra has been added, that is uh, repetition of the letter is not allowed. So for this first box, I have four choices: R, O, E, S. Right? Okay. So I have four different choices. I can put any one of that four word. So I have four many choices. Don't understand that I have put it four here. I have number of choices. Number of choices is four. Now, depending upon the choice of this first place, I have to choose the second place. That is the counting principle. That is what is the saying, that fundamental principle of counting, that an event can occur and following which another event can occur. Okay, an event can occur and following which another event can occur. Okay, so the first event, the happening of first event will influence the second event. Okay, like one can understand this by some natural example, that if there are cloud, there are some chance in rain, but if there is no cloud, there will be no rain. Kind of this thing. I am not saying that this is the perfect example. I just for convenience I am saying this thing to understand this fact little clear. Okay, so here also the thing is happening. So the choice of the first word will influence the choice of the second word. So if I choose the first one, like maybe I have chosen the first word like E. Okay, so I have only three choices for here. What are those? R, O, S. Because I have already chosen E in the first place. So okay, so I have three many choices here. Suppose I have chosen O here. I had choice R, O, S. So I have chosen O here. Okay. So how many options I have for the second position? Either R or S. So I have left with two choices. This you can see that the events are how they are influencing each other. The choice of first position, the choice of second position are influencing the choice of third, fourth positions. So I already have chosen E and O. So I have choice R and S. So I have chosen R. You can choose S depending upon you. So you have left with only one choice, that is S. You have left with only one choice. Okay. So from here, by using the fundamental principle of counting, how many number can occur, and how many number or how many number of word I can get. So the first event can have four possibility. Second event have three possibility. Third has two possibility, and fourth has one possibility. So the total number of words, total number of words is 24. Okay, this is the answer. Now, if I remove this part from this example, like I have just cut it here, repetition of the letter is not allowed. I am removing this extra condition. What I will get? So the first place here you can understand here, that is repetition is not allowed in the first case, but here repetition is allowed. So for the first case, I have four choices: R, O, S, E. I can use any of the word. So I have four choices. Fine. Now for the second position, that is the choice of the second word is not getting influenced or not getting any much affected by the first choice. It is not following. So for the second position, I have four choices again. For third position, I have four choices again. And for the fourth position, I have four choices again. So how many cases I have in this case? 4 multiplied with 4 multiplied with 4 multiplied with 4. That is 256. So from here, one can clearly see that how the number of events get reduced when I stop the repetition. So here, if I come to the first example I had discussed in the starting of the lecture. So here you can see in the case for the first case, the number of case was very much 10 to the power 4. But for the case in the second one, how many if I don't allow the number repetition? So in that case, how many case I can get? So for this, I have 10 choices. For this, I have 9 choices. For this, I have 8 choices. And for this, I have 7 choices. So the number of events will be 10, 9, 8, 7. Okay. So obviously, this is very much lesser than this one. Okay. And I will not come to this particular position right now because it is far away from right now. So up to this, you can understand that the fact that if I stop the repetition or if this fundamental principle of counting can be applied, how the number of events get reduced and how I can count them. Okay. Okay. Now let us discuss another example. That is example 4. Here also I will use the fundamental principle of counting. So what is the question? Suppose you have four different colors. Suppose you have four different colors and you need to generate different signals using two flags, using exactly two flags. So how many different signal can be generated? Can be generated. Okay. So just think one thing that I have four different colors. So let us draw three different colors. So for the first one is blue. Suppose this is one. Then the red one. Then the green one. Well, not green one. You can take some yellow color. Okay. Difficult. Those two are different, not different color. this green color, and I can use the purple one. Okay, so I have 4 different colors. Fine. Now I need to make a flag using these 2 different colors. So suppose that I have this flag, and I have this signal. So I have to use 2 different colors. Now suppose I have used green here. So here I need to color with any color without green, because if I draw the green color, then that is nothing but the first one. Fine, because I have to use the signal, so it will use exactly two different colors, using exactly 2 different flags, or you can say the different colors, different color flags, different to exactly 2 different color flags. Okay, so here the repetition is not allowed. How you can say that here they are using 2 different colors to make a flag. Now if I draw green in the both the places, then that will not make a different color. These 2 are same. So saying this much green and this much green, that is not different. In the signal, if you make a large signal and if you make a small signal, like for train line, you have saw the colors like yellow, red, and green. So if you have using a signal with a big light or a signal with a small light, that is not a significant change. But in some scenario, you have seen that they in railway they use 2 kind of signals together, like green signal and some arrow for white, by using the white lights, that in which direction he or she had to go. So that makes some combination of signals. Okay, and that usually use different colors. So I will use 2 different color for this signal. Okay, so here repetition is not allowed. Just note. Repetition is not allowed. Okay, so how many choices I have to fill these 2 positions? So for the first position, okay, for the first position, I have 4 different choice of colors. So I have 4 choices. And for the second position, I have only 3 choices. Okay, so number of possible signals is 12. 12 many signals I can have. Okay, now depending upon this, I can okay, let us discuss another example. Here I have stated that exactly 2 different colors. Now I am replacing this exactly by at least 2. Then what we will get? Let's see the answer. Why I have used the term exactly, it will be clear from right now. Okay, okay, copy, paste. Example 5, and I am replacing this exactly by at least. At least 2 different color flags. Okay, so here I have changed the term exactly by at least. So at least means I have four different colors, right? So let us replace it by 5. That will be much more better. You can relate with your book. Then it will be very much easy to understand you. This color means flags. You can say color flags. Color flags. Color flags. Okay. So you have different 5 different color flags, and you have to use those to make a signal. For that, you need to use at least 2. So at least 2 means you have different cases. One case is you have 2. You have to use 2 different colors. You have to use 3 different colors to make a signal. You have to use 4 different colors to make a signal, and you have to use. You may have to use. I am not saying that you have to use. So you meditate use that, not like that. You may have to use 5 flags to make a signal. Okay. Now for the first case, I know that 5 into 4, that is 20. Why 20? Because for the first place I have 4 choices, and for the second place I have, and for the first place I have 5 choices, and for the second place I have 4 choices. Similarly, for the second case, for the first place I have 5 choice, second for 4 choice, third for 3 choice. Similarly, for this 5, 4, 3, 2, and the fourth case is like 5, 4, 3, 2, 1. Okay. Multiply. What I will get from here, I get 60. Here I will get 120. Here also I will get 120. So these are the different cases I can consider, and depending upon this choice, I can make different flags. Now the question is, how many different flags, signals, or different signals can I generate? So using 2 or using 3 or using 4, depending upon the choice of number of flags, I can make 20, 60, 120 and 120 signals. So what is the total number of signals I can get? So total number of signals I can get is 20 plus 60 plus 120 plus 120, that is 240, plus 60, that is 320. Okay, so these are the total number of signals I can generate from the different colored flags. Okay, now from here one can clearly see that here I am using, or here I am using the concept that how many ways without repeating I can fill 3 boxes or 4 boxes or 5 boxes with different or more number of elements. So here one can say that by how many ways, the question comes here, many ways one can put in many elements in R positions, where R is less than n greater or equal to 0. Okay, so one can ask this thing. Fine. So this is called permutation. How many ways one can put in many elements in R position. This is called permutation. And in these examples, here I have done this statement for 2 position. I have put 5 flags in 2 position to make a signal. Here I have done for 3 position. That is R is 3 and N is 5. Here I have done for the 4 position. That is the R is 4 and N is 5. Similar for the 5 position. Okay, and similarly, if we go to the first examples, and here also I can see that I had 10. I had these choices, and I have to fill that without repetition. I had to fill the 10 many numbers in 4 positions. I have done the same thing here. 10 many numbers I have to put in different 4 places. So how many choices I can have without repetition? So this is what I am doing here too. So this phenomena is called as permutation. So what is the definition of permutation? Okay. A permutation is an arrangement in a definite order of a number of objects taken some or all at a time. Okay, and how this counting can be considered? So the number of permutation of n different objects taken are at a time. The without any repetition will be some number that I state. Okay, how we can state that? There is a definition of permutation and how this number can be counted. So the number of permutation, number of permutation of n different objects in R at a time where R is obviously less than n, less than equals to n, you can say, and greater than 0. I have written something wrong here, maybe. Yeah. R is less than 0, but less than equals to n. Greater than 0, less than equals to n. Okay, fine. Right here. R at the time where R is greater than 0 and less than equals to n, and the objects do not repeat. And the objects do not repeat. This is the subject to the condition. This is subject to the condition, that is the object will not be repeated. In that case, the number of permutation will be what? Let us write in green color, n into n minus 1 into n minus 2 and so on up to n minus r plus 1. Okay. Now I will tell you this formulation and how can I simplify this number by in the next class. Before that, I can write this number by this notation. NPR. Okay, I can denote this number by this NPR, which is the number of permutation of n different objects taken R at a time. Okay, now I will tell you to connect this definition with this example. Okay, so here I have 5 different flags, and we are taking 2 at a time. This R here they are saying that R at a time. So here I was using 2 at a time. Correct. So if I put the value n equals to 1 and R equals to 2 here, so putting n equals to put n equals to 5 and R equals to 2, what I will get? 5 will be there because n. Then how much I have to go? N minus R plus 1. Okay. How much I have to go? N minus R plus 1. That is 5 minus 2 plus 1. 5 minus 2 plus 1. So I can go up to this. So what I will get from here? 5 minus 2 plus 1. I am getting 5 into 5 minus 2 is 3. 3 plus 1 equals to 4. So 4. So we are getting 20. Now you may get confused that how when I have to end. So I can discuss this one again. So here n equals to 5 and R equals to 3. Fine. So how much I have to go? I can go up to 5 minus 3 plus 1. So what is that? 5 minus 3 is 2. 2 plus 1 is 3. I can go up to 3. So what will be the previous term? 4 and 5. So I have to end up to 5 minus 3 plus 1. I can end there. So how many choices I can have? 5 into 4 into 3. That is equals to 60. So just put the value n equals to 5 and R equals to the number of choices you have or number of positions you have or how many elements you are picking up at a time. Depending upon that, you can choose the R and first evaluate this value. Then you can understand where you need to stop. After that, you can write the previous numbers and you can multiply to get the answer. In the next class, I will tell some simplified form of writing this expression or writing this number using the factorial. Before that, I have to discuss the factorial, and after that, I will go to NPR and how can I write the combinations. Okay, let us stop here today.